Hello guys, so in this video we continue on the network time computing. So let's just do some recaps on these three preceding activities. As you can see here, there are three activities: then guardrails, pins, and also joins. Then these three activities need to be completed in order for cleanup work to start. So to compute, first let's take a look on the statement here. Activity 390, which is this one, cleanup. Activity 390 is preceded by three activities: 360 and 370 and 380. So the late start of each of these activities is set equal to the late start of activity 390, or at day 60. So the late finish of each activities here for guardrails, pin, and saw joints is set in accordance based on the late start of activity 390. So based on this late start, we can set the late finish for each of these three preceding activities. So subtracting the activity durations from their LF values yields the late start time. So by subtracting the duration from the value of late start, so you can get the late start times. So the late start times for activities 360, 370, and 380 are correspondingly equal to 57, 55, 59. Let's take a look in details. So you can see here the late start of 390 is set as late finish for 360. So you have that day 60. The duration of the activity is 3 days. So 60 minus 3 days, you get 57. Day 57 is the latest start day for guardrails. For painting work, it's also the same, but the duration is 5 days. So 60 minus 5, you get 55, day 55. And for activity of saw joints, duration is 1 day. So saw joints need to be start the latest at day 59. Okay. Next, we take a look at burst activity. Burst activity, to obtain the late finish of activity 350 here. We have activity 350 here. The late start of the immediately succeeding activities are noted. So these are obtained from figure 5.1 from the book if you want to do your own revision, as 57 for activity 360 here. 57, the late start for the succeeding activities for guardrails, and 55 for activity of painting 370 activities. The latest start is at day 55. So keeping in mind that activity 350 must be finished before or either activity 360 or 370 can begin, it is logical that activity 350 must be finished no later than day 55. So activity 350 must be finished based on uh, the earliest day between these two. So based on this, painting work is the earliest. Painting work is the earliest at day 55. So based on that, that is going to be your latest finish for the preceding activities. Okay, so we set at day 55. So your strip deck latest need to finish by day 55. So that paint, so it won't exceed the latest start date for painting works. because this is the earliest activity need to be started uh, by if we compare between these two burst activity. So if it is finished any later than this, the entire project will be delayed. So if strip deck finish at day 57, for example, so your painting work will start at 57, so there will be a delay lah. So you won't meet your uh, project duration and end date. The rules for this and other burst activities is that late finish value, the late finish value for such activity is equal to the earliest, as mentioned before, earliest or the smallest of late start of the following activities. So you compare between the two uh, succeeding activities, which is the smallest LF value or the earliest I should start. So that earliest date becomes the late finish date of the preceding activities. So to calculate your late start, your LF is taken as 55. So minus duration, you get your late start value for strip deck work at day 52. So let's take a look at another example on our master network program. For example, let's take another example that involves burst. Can get burst. Yeah. For example, this one, this activity. This activity involves burst activity where moving activity need to complete before we can proceed with the abutment works and excavate abutment and mobile. So between these three activities, activity 80, 90 and 100, the earliest would be 15. The earliest late start will be 15. That's why we take 15 as our late finish for the preceding activity, which is the move in activity. So your late finish for move-in activities is 15, and 15 minus 3, you'll get 12. That is your latest start for this activity. Next, we also want to take a look on two preceding activities combining into one activity. Uh, for example, this activity. For example, we take activity 190. 190 forms and rebar footing number 2. So it has two preceding activities, which is street footing number 1 and drive past abutment number 2. So the latest start for street footing, latest start for activity 190 here. So the latest start is day 30. So latest start is day 30. So the preceding, but as you can see, the preceding activity, street footing, number 1 and drive past, is set at 24. So why is that? So this is because the street footing number 1, activity 190 here is actually burst activity. So it has another requirements on it has another succeeding activities beside activity 190. It also has succeeding activities of 180, which is form and rebar. So by comparing between activity 180 and 190, so you see that the smallest late start will be on the 25th on day 25. So that's why you set your late late finish for street footing number 1 to be 25, day 25 instead of day 30. That's why I set day 25 instead of day 30. So the same goes for activity of drive piles here. Drive piles, it actually has two succeeding activities. It is actually a burst activity. So you have a demo of pile driving rig, which latest start should be at day 24. So by comparing these two, day 30 and day 24, so day 24 is the smallest latest start. So it will become your uh, late finish for activity 140 drive past abutment. So basically it's the take the smallest. If it is burst activity, then it takes smallest. If it's a three combined activities combined into one, so that one succeeding activities is the it define the late finish of the preceding activity. So let's take a look on another example. Example here you have cleanup activities, activity 390. So cleanup activities, it has three preceding activities, which is guardrails 360, pin 370, and soil joints. So as we've discussed before, day 60 becomes the late finish. Latest start of cleanup becomes the latest finish for guardrails, pin, and soil joints. So on another example, for pour and cure deck, activity 340, so day 49, which is the latest start for this activity, becomes the latest finish for the preceding activities. Is to activity 315 and 330. So 490 minus 0, 49 minus 4. So you get your latest start for this each activities. Then we also have this combined activities of street cure and fabricate deliver girders, combine it to become set girders. So 43 becomes the latest start of set girders become the latest finish for these three activities, these three combined activities. And also street cure, what is different here is that street cure apartment number 2 also have another activities succeeding it, which is activity 300, 300, and 310. But as the latest start of among these three activities, the smallest one is set girders. So set girders latest start of set girders is become the latest finish for street and cure. So that's all the example. You can go and have a look more on this slide just to help you train more, uh, help you master the network time computing techniques so that you can develop a complete network diagram CPM for your project. So in summary, the backward pass computation proceed from activity to activity until the start of a project. So from right to left, backward pass until the start of the project. So all that is involved is repetition of the rules. You need to remember the rules, just a basic like logic, job logic. What need to be start first and what is the following activity. So the rules is simple, just logic. And in making actual network calculation, of course, the late start and late finish and late start values would be calculated directly on figure, as in figure 5.1, with times being entered into the activity box as they are obtained. So basically, you have a empty box with network. You have your number, and then your early start, early finish. Then you have your at the bottom is your this is duration, so, and early late start, late finish. So these are all empty at first, and blah 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 here. So these are all empty first, and then you enter the box. You estimate the value of duration, and then you keep on entering the start date, end date, and then latest start and latest finish. So it is encouraged to verify all the early and late activity times as a test of how well the rules of computation procedure have been mastered. So you can uh, keep on practicing using this figure, the previous figure as shown in the slide, so you can help you master the technique. So this is a more simplified. So hopefully you guys understand the network computation. So in the assignment and exam, it will be you doing your network diagram, a complete network diagram, starting from the planning up until you finish with the network diagram complete with the latest start and latest finish. Next video will be on float. The float we want to calculate how many days available for any contingency or uh, any delay due to some unforeseen circumstances. That's all. Thank you. See you in next video.